than confining to few problems. There's a wedge and and we have a particle here. Alpha given, mass of the particle given, initial velocity of that is given. A particle of mass m1 collides with a wedge just above point A. To make understand the problem little bit, I made above, just above that one. It will come and collide here only. So we can't draw diagram. I'm just shifting it up here. The wedge starts to move towards left with a velocity v2. After collision, the wedge will start moving towards left. Okay, there's a diagram. Now after collision. So after collision means, let me show that during collision, what actually happens. Let me have like this. During collision, how the impulse will act. The impulse here will be, I'll remove this alpha. J will act here and the impulse on the wedge will be in this direction. Is it okay? So there's a line of impact. How do the wedge, after collision again, the wedge will move. Yes, I can draw the diagram. How the wedge will move? Because of impulse acted, the wedge will acquire velocity v2 is telling. How the ball, what is the possible direction? The ball will have velocity v1x, v1y. Let's check what can happen. Definitely the wedge should move towards left, no, because of j sine theta. This is a very generalized case, so you can work out many numericals related to this information. So can I conserve momentum along x-axis? Now one more thing, look at this one, component of impulse. This impulse will act vertically down, no, j cos theta. And because of there'll be an impulse by the ground on the wedge. Why do this impulse will come? Because of component of j sine alpha, j cos alpha. J cos alpha will act vertically. So there'll be impulse by the ground on the wedge. And there's a more troublesome. Now in which direction momentum is conserved? Looking at the diagram, please do. I have showing everything sequence here. Can I conserve momentum along line of impact? What is the line of impact? The direction in which the impulse is acting. There's a line of impact. Can I conserve momentum along line of impact? The answer is no. Plus j minus j, okay. But what about the component of impulse by the ground on the wedge? Will be unbalanced, you know? So momentum is not conserved along line of impact. Can I conserve momentum of the wedge particle along y-axis? No. This unbalanced thing is there. Then only along x-axis it is conserved. Is it okay? No? So fine. First thing, the net impulse on the system along x-axis 0. So therefore, initial momentum equal to final momentum. What is initial momentum? M1 u naught. Anything directed towards left, you can take it positive. Finally, m2 v2 minus m1 v1x. I know m1, I know u0, I know m2, I know v2. Let me substitute, I'll get the v1x. So what is m1 value? m1 0.5, u0 40, 4 kg, and v2 this is 5, m1 0.5. 4 5 are 20. I think this will be 0. So immediately after impact, what will happen to the particle? Will rebound vertically. V1x will be there. The wedge will be moving towards left, and the particle weapon will rebound vertically. It's asking heat generated during collision. How to calculate heat generated? The loss in kinetic energy. So heat generated should be equal to initial kinetic energy m1 u0 square by 2 minus m1 v1 square by 2 minus m2 v2 square. Why x component? It has become 0 from the data given. This will be heat generated. Then maximum height reached by the shell or ball, that one. So this is the shell is telling a maximum height reached by the shell. Maximum height reached by the shell should be equal to okay, the problem has become simple. Now, distance of point A of the wedge from the shell when the shell strikes the plane. What does it mean? What is the path of this ball? The ball will ascend, then will descend, no, finally. And what is the displacement of the point A of the wedge? So what is this total, the whole problem is? So this is initially at rest. It will collide after collision. I think. Yeah. I have to draw a diagram. This is. I'll show small diagrams. It will be much easier. Initially, and the wedge will start moving. The shell after collision will have only y component of velocity, the point A, and the shell, what will happen? It will ascend certain height, and finally it will descend back. No. Problems of like this are very important. Okay, got it now. The shell, what happen, will come back and rebound, and it will attain some maximum height. Is asking this distance. Can we calculate? This happened at t equal to 0, no? And what about this time? 2v1y by g. In that instant, this will move with a speed v2. So what is the distance now of the shell when striking the ground? S should be equal to v2 into t, v2 to v1y by g. Getting the understand the last part of the problem, the distance of the point A from the shell when the shell is about to strike the ground. Because how it will move, the shell will move vertically up, then ascend, then